Your dev server is listening on your laptop, bound to localhost on port 3000. A teammate says, "Can I see it from the lab server?" You run one SSH command, and suddenly port 9000 exists on that server. That is SSH remote port forwarding. The sharp question is not, did the tunnel work? The sharp question is, who can now reach port 9000? If you cannot answer that, you may have turned a private test service into an exposure. Remote forwarding is the inverse of the local forwards we covered earlier. With local forwarding, your workstation opens a local listening port and sends traffic toward the server side. With remote forwarding, the SSH server opens the listening port, and traffic travels back through the encrypted SSH session to a service reachable from your client side. That is why the flag is -R. It exists for legitimate administration, showing a local build to a remote lab host, giving a remote job a temporary callback endpoint, or connecting a server-side tool to a service that only exists on your laptop. Useful, yes. Also easy to misunderstand. Read the forwarding spec from left to right, but keep the sides straight. In -R 9000:localhost:3000, port 9000 is the listener on the remote SSH server, the machine I am calling host. When something on that remote side connects to 9000, SSHD does not handle the application itself. It hands the bytes into your SSH session. Your SSH client then opens a connection to localhost port 3000 from the client machine's point of view. That detail matters. The word localhost in this command is not the server's localhost for the final destination. It is your laptop's localhost after the traffic crosses the tunnel. Here is the smallest safe lab. First line starts a simple web server on your own machine bound to 127.0.0.1, port 3000. Second line opens SSH to host. -N means do not run a remote shell command. This connection only carries forwarding. -R asks host to listen on port 9000 and send connections back to localhost 3000 on your client. Third line is run on host. Curl the loopback address and you should see the Python directory listing response. Fourth line asks SSHD what its effective gateway port setting is after parsing config. The final line is the OpenSSH default. A clean real-world pattern is a temporary callback from a lab server. You are developing a webhook receiver on your laptop at port 3000. The lab application runs on host, and it needs to post test events somewhere stable from its own point of view. You start the local receiver, open the remote forward, and configure the lab app to call http:/127.0.0.1 9000 on host. The traffic comes back to your laptop without opening your laptop firewall. When you close SSH, the published port disappears. In a team, record who opened it, why it exists, when it expires, and what service sits behind it. The common mistake is assuming remote means public. By default, OpenSSH uses GatewayPorts no. So the remote forwarded listener is bound to loopback on host. Processes and users on host can reach 127.0.0.1.9000. The outside network normally cannot. If an administrator sets GatewayPorts yes, remote forwards may bind to wildcard addresses, making them reachable from other machines subject to host firewall and routing. GatewayPorts client-specified lets the client request a bind address, which is more flexible but delegates a serious choice. Use SS on host to see what address is listening. Audit remote forwards like open ports, because operationally, they are exposures. Remote forwarding sits between convenience and access control. It connects directly to local forwarding because both are TCP tunnels with opposite listener placement. It connects to jump hosts because administrators often use a bastion as host. It connects to reliability topics because a remote forward only exists while the SSH session is alive. Keep alives or a supervised client may be appropriate for approved workflows. Most important, it connects to server policy. The server decides whether TCP forwarding is allowed, whether remote forwarding is allowed, and whether remote listeners can be reached beyond loopback. For a 5-minute practice task, use only your own machine and your own VM. On your laptop, start the Python server on port 3000. Open the -R command to the VM. In a separate SSH session to that VM, curl 127.0.0.1 on port 9000 and confirm the response came from your laptop's directory. Then run SS on the VM and look at the local address column. Finally, check the effective gateway ports value. Do not change it yet. The goal is to prove the default reachability boundary before you experiment with wider listeners in a controlled lab. 3 beats to keep. First, -R publishes a client-side service on the SSH server side. In our example, host port 9000 reaches your laptop's localhost port 3000. Second, the OpenSSH default gateway ports no means the published port is loopback-only on host, not automatically internet-facing. Third, changing gateway ports changes the audience, so treat remote forwards as exposure events and audit them that way. Tomorrow we keep building the practitioner layer of SSH. New SSH episode daily on this channel, plus the daily ranked CVE brief for defenders.